If you like this presentation, please follow our YouTube channel. I want to start this presentation by explaining the current evidence supporting the use of flywheel training in sports. Here you can find the publication of Raya-González that summarizes the effect of flywheel training on jumping performance, sprinting and change of direction performance. As you can see, the evidence in our hands show that flywheel training has a positive effect on this parameter compared to control conditions. Since my background is in team sports and in particular in football, I am particularly interested about the application of this technology in such sport. Very recently, my group and I have published the systematic review that you can see in these slides. The aims were to evaluate the current literature surrounding the chronic effect of flywheel training on the player physical capacity and to identify areas for future research and to establish guidelines for its use. 11 studies met the inclusion criteria and were included. This is a very important point because only 11 studies investigate flywheel training in football, and this is not a high number to establish strong recommendations. The present review is mostly in agreement with previous systematic reviews and investigation reporting the positive effect of flywheel training with sport and athletic populations. These studies in the review reported a training duration that ranges from 6 weeks to 27 weeks, with a volume ranging from 1 to 6 sets and 6 to 10 repetitions, and the frequency from 1 to 2 times a week. The take-home message of this review are: Point 8. A diverse range of flywheel training intervention can effectively improve strength, power, jump, and change of direction measure in male soccer players of different levels. The point B. The current literature suggests contrasting evidence regarding the flywheel training effect on sprint speed and acceleration capacity of soccer players. This doesn't mean that flywheel training cannot improve these parameters, but simply that we don't have enough evidence for the moment, and future research is needed on this specific topic. The evidence that we have in our hands are not only limited to the male population, because recently we have published another paper that showed that flywheel training is a safe and time-effective strategy to enhance physical outcomes with young and elderly females. This systematic review suggests practitioners to prescribe flywheel training as an effective way to prevent muscle injuries or falls in the elderly population, as well as it is a very important stimulus for physical enhancement in the young female population. However, a lack of clarity still exists on the appropriate flywheel training dose, frequency, and intensity. Probably the most important limitation of this review is the number of studies included, that is 7. Therefore, much more research is needed on this topic and on this population. Now that we know about the flywheel training background, we can have our first research question, which is: can we offer precise recommendation on how to accurately design and prescribe flywheel exercise, especially in elite athletes? The answer is yes. In 2020, I have published with Antonio De Loiacono the following paper in Frontiers Physiology. This study is the first to summarize the guidelines for the use of this training method in athletes. About training intensity, a range of inertial load 0.05 0.11 are generally recommended to induce chronic adaptation and enhance the athletic performance. About training volume, the protocol should use multiple sets from 3 to 6 and repetition from 6 to 8. About training frequency and duration, clear guidelines are missing, but a 2-3 session per week for a duration of 5 weeks appears sufficient for induce positive adaptation. Now we can proceed with the next question. Do we have evidence to support the use of flywheel strength training for muscle injury prevention? Again, flywheel strength training may also be implemented as an injury prevention strategy due to its protective role related to the eccentric component. This could be particularly important for hamstring muscles. And as you can see in this paper, a training frequency of 1 or 2 times a week, inertia using the study of 0.11 kg/m², using both leg curl and squat exercise in a population of elite Spanish soccer players was a valid training method to achieve this aim. As you can see, I have added the 3 arrows. The first show that injury severity is decreased, and the other 2 show that flywheel training has been positive for both counter movement jump and sprint performance. We have also another study published by us in 2003 that showed the capacity of flywheel training to reduce muscle injuries. The training protocol consisted in 16 sessions for a duration of 10 weeks, involving professional soccer players. This study reports a reduction of minor and moderate hamstring injuries compared to a control group. To summarize this evidence that we have in this topic, in 2021, I wrote another paper titled Implementing Strength Training Strategy for Injury Prevention in Soccer. You can see in this paper on the right side that flywheel training, if proposed twice a week with a volume per exercise of 3 to 6 sets and 6 to 8 repetitions, could reduce the likelihood of muscle injury. Here I have reported a couple of videos of exercises we are studying at University of Suffolk in this moment. The first is a flywheel single leg curl. The second is a single leg hip extension, which are common exercises used for hamstring injury prevention in football. So we'll start from the single leg flywheel curl. This exercise is done with the Desmotec device. As you can see, you can control very well the eccentric phase of the exercise. Now we are watching the hip extension exercise with the same Desmotec device. And also in this case, you can see that you can control very well the eccentric phase of the exercise. Now we can move to the second part of this presentation. As we have seen so far, flywheel training in sport is supported by several scientific studies, but limited information is currently available about its periodization. Therefore, the aim of this article that you can see in this slide was to provide a methodological basis for the periodization in team sports. Training periodization must consider two key aspects for its development. Firstly, the training load components that determine the specificity of stimuli, intensity, volume, training frequency, and training variation, for example, exercise selection and training mode, provide transfer to the sport and continual stress for adaptation in line with the specific aim of the program. Secondly, the competitive calendar, microcycle, and the season period, mesocycles and microcycle, will define all the strength quality to train and the proper amount of load for each training session, but also the strength training program characteristics. These slides report a training microcycle for a handball team in pre-season. During the pre-season or period with a single competition per week, a training frequency of 2 weekly sessions would allow for greater chronic adaptation. The first flywheel training session, match days -4, should be focused on injury prevention and strength development, involving multiple sets exercise with high inertial load, while the second session, match days -2, may have a focus on power development using lower inertial loads and a lower overall volume. In this second table, there is an example of an in-season weekly program for a professional soccer team, 1 match per week, which is characterized by the subdivision of the team into 2 groups, starter and non-starters, based on the player involvement during the previous match. On match days +2, practitioner may plan a flywheel training session for non-starter, focus on injury prevention and strength development, using a relatively high inertial load, for example, higher than 0.050 kg/m², and a volume of 3-4 sets per 6-8 repetition. However, remember that the intensity and volume variable depend on the exercise used and player strength level. Starter player instead should be mainly recovering within 48 hours from the previous match. Therefore, flywheel training has not been prescribed for this group in this specific table. On match days -4, 72 hours after the match, starter should be ready to perform an intensity flywheel training session, while non-starter who have performed this session the day before may have flywheel session with a focus on power development. Before the conclusion of this microcycle, starter and non-starter may perform a further session with the focus on power training to have another flywheel training session per week using a microdose principle. In this slide, I want to show you this study that uses a training frequency of only 1 session a week, which is a very typical training frequency in football. In this paper, we compare 2 training methods, flywheel training and traditional resistance training. The volume was equivalent for both groups, 6 sets of 8 repetitions. The flywheel training group use inertial 0.11. The traditional resistance group use a 80% 1 RM. As you can see, the session was performed in the match days -4, but we didn't have a second session during the week. We could have offered better results in the long run. In this table, you can see that some improvements were found in favor of the flywheel training group in shuttle performance and agility performance. Please see, for example, the 2 blue arrows reported in this table that show the significant difference between the groups and the pre-post effect. In the slide 19, instead, you can see that there are some green arrows. These green arrows report improvements in favor of the traditional resistance training group, in particular for the concentric contraction. But greater improvements were found in favor of flywheel training in the eccentric contraction. In this case, you see the blue arrow. Here we have another study that uses a randomized trial to determine the effect of strength training on motor skills variables in young handball player in season. 34 young male handball players were enrolled in this study. You can see that the protocol of the study on the right used a 8 weeks training duration with a training frequency of 2 times a week. As you can see, both flywheel training and cable resistant training group performing the same exercise and same volume. The perceived exertion, RP, of the 2 groups was the method used to determine the increment of intensity during this protocol. In the table, you can see that both training methods have incremented the performance of the athletes, in particular in change of direction performance and repeated change of direction performance, but not in linear sprinting performance. In this specific test, in this specific study, we use a sprinting performance 20 meters. If you remember at the beginning of the presentation, I said that linear sprint performance sometimes doesn't improve following flywheel training, while change of direction performance generally improve. Before concluding this presentation, I want to present a third scenario. We know that congested fixture periods are a common scenario in professional sport, and players need to compete 3 times a week with a limited amount of time available for training. In this case, practitioners should be encouraged to plan a single session of flywheel training focused on power development, and if there is the opportunity, to implement additional microdose of flywheel training. Instead, high volume and high-intensity training sessions should be avoided during this week because the players don't have enough time between training sessions and match to recovery. For example, some players could have some DOMS or fatigue on the match day. I want to conclude this presentation with a brief summary. This paper, as you have seen in this presentation, has analyzed the most recent evidence and summarized some of the characteristics of strength training periodization. In detail, it has discussed how to periodize flywheel training per season, in season, and during congested fixture period in 3 different sports. Finally, you can see that this paper has been published in a special issue titled The Science of Flywheel Training in Frontiers Physiology. Therefore, I take the opportunity to thank my co-editor here reported, Jose, Sergio, and Xavier. Thank you very much for your attention during this presentation. If you have any questions related to what I've just explained, please contact me at my email address. Thank you very much.